Hello guys, this is Anum Pirkani. Today in a small video, I'm going to discuss different features behind electric vehicle charging. Now starting off, electric vehicles runs on batteries. These batteries are somewhat similar to the ones you guys use in your phones or even your laptops. Of course, they have completely different set of features and characteristics, but the basic idea is similar, as in your phones, your laptops run on batteries, and similarly your electric vehicles run on car batteries. And as you drive your vehicle, the battery discharges, and at the end, you have to recharge your battery. Now, you can recharge a battery in either your homes or in public places. It depends upon the type of charging or the speed of charging you need. Now, before going any further, I'm going to introduce the factors which affect the charging capacity of a vehicle. It depends upon the type of vehicle, the battery capacity. It is easier to imagine that if a battery has greater capacity, of course, it would take more time to charge, but it would, of course, take more time to discharge as well. And then the maximum charge rate a vehicle can accept. If a vehicle can accept a greater charge rate, it would charge faster as compared to a vehicle which charges at a slower rate. And then the type of charging station, I'm going to discuss this in a bit more detail later in the video. Now, another factor affecting the charging is basically the battery's current status. It basically tells how empty the battery is when you put it on charging. Now, if a battery is completely empty, it is going to charge quickly. But once it starts to charge up, then the charging capacity, or let's say the charging speed, decreases. The charging capacity, of course, remains the same, but the charging speed is going to decrease. So therefore, you might have seen that in most of the cases in different technical documents, the charging capacity or the charging time up to 80% is given. So this is because if, let's say, your vehicle takes 1 hour to charge from 0 to 80%, it is almost going to take similar time to charge from 80% to 100%. So it is somewhat also better to charge your vehicle till 80%. And then the last factor, or let's say the last important factor, is the battery age. If your battery is new, it is going to charge quickly as compared to a battery which is like 3, 4, 5 years older. All the later points I'm going to discuss in the video somewhat depend upon these factors. So therefore, I thought it's better to introduce them earlier in the video. Now, very briefly, I'm going to discuss some of the technical specifications behind charging power and charging time. So in case of a single phase supply, the AC charging power is dependent upon the voltage and the current. Now this voltage is basically the single phase AC voltage, and the current is of course the grid current. However, in case of a three-phase supply, the power of AC charging increases because of the three-phase, and therefore it depends upon the square root of 3 times the voltage and the current product. Of course, we can see that in case of a three-phase supply, the charging power is going to increase, and therefore we can assume that the charging time is going to reduce. And ultimately, the battery capacity depends upon the charging power and the time of charging. So a battery with a greater capacity is going to take more time to charge, but of course, as I described earlier, it is going to take more time to discharge as well. Coming to its differences between a three-phase and a single-phase supply. A single-phase supply basically runs on 230 volts as compared to a three-phase supply which runs on around 400 volts in case of the UK or other European countries. Now, three-phase is much more common in case of businesses and factories. However, at some additional cost, you can have a three-phase supply at your homes. As I described earlier, the charging time reduces when the power of charging increases. As we can see that in case of a three-phase supply, due to higher voltage, the power of AC charging increases, and therefore in comparison to a single-phase supply, it reduces the charging time. However, if you want to install a three-phase supply at your home, you're going to need some extra cost. Now coming towards the types of chargers. So there are two main types of chargers. One is the slow charger and other is the fast charger. The slow charger is also called as an AC charger, whereas a fast charger is called a DC charger. Slow chargers can take somewhat around 12 hours or so to charge the battery from 0 to like 80%. However, fast chargers can charge a battery up to 30 minutes or so. Therefore, of course, we can say that fast chargers are much better, and then it reduces the charging time drastically. But one should always minimize the use of DC charging because although they are convenient, but their prolonged use can damage the battery lifetime. Now coming towards the type of charging. So there are three different types of charging defined: the level 1 charging, the level 2 charging, and the level 3 charging. Well, level 1 charging is the most simplest of the charging. It takes 120 volts. It is an AC charging technique. And to charge the vehicle, you just have to plug the cable in the wall outlet of your homes. Level 2 charging is also called as the AC charging techniques. It takes 230 volts. Again, it can run on phase 1, single phase, or 3-phase supply. And then for a home charger, this is the most common type of charging technique used. It takes around 5 to 12 hours to charge the vehicle in comparison to the level 1 charging, which takes around 24 plus hours to charge the vehicle. Level 3 charging is the DC charging. It takes around 300 to 1000 volts, but this capacity is like increasing on the daily basis. It has an AC to DC rectifier built in this charger, so it is of course bulky, but it charges the vehicle quickly. And then to charge the vehicle to up to 80%, it can do it in like half an hour or even 45 minutes. But these chargers are expensive and they are much more common in public areas. It is not like too much feasible to install these expensive chargers at your homes. So for home purposes, the level 2 charger is the best option to go for. Well, now coming towards the charging power levels. As I described earlier, the most simplest one is the level 1, which takes 120 volts at around 16 amperes of current supply, and the charging rate is around 1.9 kilowatts. So it charges at about 5 miles per hour. Therefore, it is not that convenient if you are going on a long drive or if you want a quick charging. Now coming towards level 2, it can run on single phase, on 3-phase with different current ratings, and as we are going to increase the current rating, the charging power increases and therefore the charging time reduces. Towards the end, the level 3, the DC charging, it has a power capacity of somewhat greater than 50 kilowatts, and then you can charge almost greater than 140 miles per hour with this type of a charger. However, as I described earlier, these levels strictly depend upon the state of charge, the battery current status, the weather conditions, the battery capacity, the type of charger, etc. There is one more very important parameter to consider here. So let's say the charging station has a charging capacity of around 3 kilowatts and your electric vehicle can charge at a capacity of somewhat 6 kilowatts. Now, due to the difference between the two, there has to be a compromise, and therefore the charging will still be done at 3 kilowatts. So no matter what the capacity of your vehicle is, it is going to be charged at the capacity of your charging station. But again, an important factor to consider this is that if, let's say, the charging capacity of the charging station is greater, let's say 6 kilowatts, but the capacity of the electric vehicle is less, in this case, let's say 3 kilowatts. Still, because a vehicle cannot accept a power greater than 3 kilowatts, therefore the charging will still be done at 3 kilowatts. Therefore, it is always recommended that if you are going to buy a charging station, always consider the charging capacity of your vehicle. The more the charging capacity of the charging station, the expensive it is going to be. Therefore, it's kind of useless to waste all this money buying a charging station with a more capacity, but having an electric vehicle with a lesser capacity. Now, towards the end, I'm very briefly going to discuss the limitations of fast charging. So with fast charging, one of the biggest limitation is that the line losses increase, because line losses basically depend upon the square of current and the resistance. With DC charging, which was fast charging, the current is higher and therefore the line losses increase. And then with fast charging, the battery lifetime reduces. There are the issues of thermal management, and then the cables are much thicker. So it would be difficult to lift the cable and plug them in the sockets or the charging stations. So with this, I'm going to end the video. I hope you liked it. If yes, please like, comment, and subscribe. More videos are coming soon. Thank you.